So section 1.4, again, talking about decided limits and continuity. So we talked about the ways we find limits, right? We plug in, we have a table, we have a graph. Ways to find limits. We have plug in. You have using a table. We have graphs. Right? When you're plugging in, you can do things like factor or simplify, factor, simplify, etc. Table, you're creating values that are very close to the value, right? You want to get to very close to it. So like if you're trying to get to 0, you're going to 0.1, 0.01, 0.001. And a graph is a great way to locate the value of a limit at a certain point. So here's like C, and you want to locate where that value is, the limit at value of C. You can use graphs to find limits, right? We can use tables, and we've plugged in various things we've done to find limits. But, and we talked a little bit about this, but I want to formalize it. When does a limit not exist? And this is called a point of discontinuity. A limit does not exist when the graph is discontinuous. And there are a few types of discontinuities. Or maybe not necessarily not a limit exists, but a discontinuity. So the first type of discontinuity is a hole, right? This is a graph that's got a spot where it doesn't exist. Right, this value here, here's my value of C. So one type of discontinuity is a hole. Another word for a hole, we call this a removable discontinuity. Removable. Discontinuity. And removable because we can plug the hole. If you put a value, if you fill that dot, then the graph becomes continuous. So it's removable because we can fill the space where the hole is, right? So that's a type of discontinuity. It breaks the graph, right? It's not smooth. We fall through. Now think of continuity like, can you skateboard across the graph and not fall through a hole, and not fall through the graph? When there's a hole in the graph, it breaks it. So imagine a skateboard, right? Skateboard falls through. Here's a skateboarder on their board. Skateboarding, fall through. Not continuous. So that's one type of discontinuity, is a hole. A hole, also called a removable discontinuity. Second type of discontinuity is a jump discontinuity. And this is when you have a graph where one side of the graph goes to one spot and another side goes to another spot. And a jump discontinuity is not removable. There's no hole we can plug, right? It's too far of a gap. And there's a gap between the two sides. Our skateboarder, right? Our skateboarder falls off the hole, right? Here's our skateboarder. Woo! Flies away. Or falls down, right? Not continuous. So jump discontinuity is a graph that has a space here, right, where one side ends on one spot, one side ends on another spot. So that's another type of discontinuity, a jump discontinuity. Third type of discontinuity is, what do they call it? They have a certain word for it. I want to call it just it's an infinite discontinuity. An infinite discontinuity. And that's when we have a graph that has like a vertical asymptote. So say we have a graph that goes like this and then like this. So here we have a vertical asymptote. An infinite discontinuity is also non-removable. Infinite discontinuity because you're going to infinities, right? You're going to infinity. Your skateboarder is going to go forever, and they're not going to smoothly connect between the graphs. So that is an infinite discontinuity. Right, skateboarder goes up to infinity or falls down to negative infinity. You're discontinuous. Even if you had a graph that was like, say you had another type of graph. And say that one side went to positive infinity and the other side also went to positive infinity. This is still not continuous. There's a break, right? Like a circle. There's a break in the graph, right? A break in the graph. Break in graph. So it is not continuous. Why is my thing continuous? I don't know why my pen's being all weird. Infinite discontinuities. Why is this acting so funny? All right. So number 4, last type, oh great, is what we call, this is a, again, I'm trying to remember the words here. They called it an oscillating. O-S-C-I-L-L-A-T-I-N-G bus. What is going on? Oscillating. Want to see the A here? Oscillating. Hold on. Discontinuity. I'm not going to try to write that word. An oscillating discontinuity. So this kind is where you have a graph that looks like it's wiggling back and forth, and then wiggles like a whole lot, and then that's a real bad graph. Hold on, everyone. Let me see if I can do better here. I don't know, my pen is acting up today. So it's when you have a graph that it's like this. It goes, oh, it's this program. Wiggles, and then wiggles, and wiggles, and wiggles, and it wiggles like a whole lot. It goes up and down really like quickly. Anyway, best I can do, everyone. But this part here, this oscillation, is where the graph, like if we try to find what is the graph approaching at this spot here, let's say this is the graph, let's say this is the equation, right? You don't know what it's reaching at this point because it's going up and down so quickly, it's hard to nail down. An oscillating discontinuity, also non-removable. Also not a removable discontinuity. Okay? How much time we have? Oh, good. 10 more minutes. So these types of discontinuities, right? These types of discontinuities, we're able to recognize them. Right? This oscillating discontinuity or a infinite or jump discontinuity by visualizing the graph and testing if these limits exist, right? So the thing I want to do right now, let me stop this for a second. Let me see if I can restart this program, make it work a little bit better.